Okay, I think we can start. So happy to see everyone on this webinar. And let me introduce it to you guys. So today we're gonna talk about React Native and the role of performance, the strategic role of performance in the product development, and how it actually affects business and how to troubleshoot it. During this webinar, feel free to leave your questions in the chat, and at the last minutes of the webinar, we're gonna walk through the questions, and I'm gonna do my best to answer those. Okay, so let me introduce myself first. So my name is Ivan. I'm CEO and founder of Techstack. Also, I'm founding head of engineering in different products, like couple products over last years. I am having, I think, more than 15 years of engineering experience. I've been playing different roles in my career. Started with software engineer, then become solution architect. It's been a long path, basically. But what's important for today is React Native and React Native expertise. At Techstack, we actually working with React Native for more than 7 years. And I'm excited to share our outcomes, some of the case studies we have, and also some of takeaways over these years, which we actually been through, and share some challenges we faced and how we actually dealt with those. And to start, we're gonna start with the why question, and why business actually need to take care about performance in the mobile apps. For most of the people, it's pretty obvious, but if you look behind the scene, it actually affects business a lot, and we're gonna walk through some of the points. So first of all, it's long-term sustainability. Basically, performance, like bad performance, if it actually included in the architecture or excluded the preventive performance issues initiatives in the architecture, it's becoming like a snowball. And as business grows, as product keeps developing, the thousands of code commits, making it actually impossible to keep going with the same pace, to keep the brand the same, keep the trust with user the same. And we lead into second point, which is the trust and retention. Most of the mobile apps we've built are B2C, and we care a lot about what users actually are facing while they're using apps we build in. And the cost of bug in B2C apps is significant. And cost of bad performance is also significant. It actually generates slowly generates frustration, which leads to bad App Store ratings and bad retention for the business, which leading us to App Store ratings. So any onboarding funnel for any product includes downloading app for the mobile app products, downloading app. And businesses spend a lot of money to actually drive user to that download app page. And when user sees the low rating, if it's like less than 4, there is a doubt which actually this critical action may not happen. There is doubt in the user's mindset. But if ratings are high, it actually improves the confidence in the product and leading to strengthening the stronger funnel, like onboarding funnel. So we need to take care of App Store ratings, which can suffer. App Store ratings could suffer from the lack of high-performing behavior of the application. Another reason like why business needs that is for the content-heavy apps, if it actually includes certain images or videos or user-generated content, even plain text, architecture may not handle content growth. So if users will start uploading and generating content, for the low amounts of content, it might be fast, but for the large amount of content, it affects not only the focused areas where content is placed, but overall app performance is also affected. And refactoring at scale is becoming really expensive, because if that snowball of technical debt is becoming the problematic, like problem for the delivery, if our engineering development cycle time becomes like larger and larger, longer and longer, then plus technical debt is growing, we cannot actually deal with it with the same pace to keep it low. At some point, product managers won't receive that expected pace of the delivery for the software development. And at that point, engineers rise in hand and saying like, hey, we gotta do something. We need to include refactoring. And that refactoring at different products could actually lead to months of work, which is the disruption for product roadmap and even company strategy in some cases. So performance is one of the key indicators of the success for the app. And let's talk about React Native in general a little bit. Why React Native is good, like for what things React Native is good and for what things React Native is not that good. And we'll start with the good part. So over more than 7 years of experience, we actually gained certain expertise on how to make it high performing and how to move fast with React Native. And one of the, we highlighted here some of the key benefits of it. So basically what we faced with is cross-platform development actually makes businesses going faster to the market. And in general, React Native is very good for a lot of functionality, for producing a lot of functionality if it's not actually animations heavy. So cross-platform is a big win. We don't need to have Android, Java team. We don't need to have iOS Swift teams, a team working in parallel to deliver to users of the two different marketplaces. And care about synchronization between those two teams. The single code base, it actually delivers to the both marketplaces simultaneously. That's amazing part. Also, React Native is cost effective. I would say that in our experience, the initial releases of products are extremely fast. We've done some of the MVPs in even in a couple of weeks, like really simple stuff just to get users. But in case if we were picking up the native way, like going with Swift and Android, I think the same scope of work would take us at least a couple months to actually deliver the same result. Consistent brand experience is one of the benefits here. Basically, the same code base, same UI is delivered on Android and iOS, regardless of the UX rules defined by Google, by Android, and by iOS. So by building React Native apps, we actually introducing the same UI for the both platforms. Also, React Native is pretty much scalable solution. because it's based on JavaScript, and JavaScript community is the largest in the industry. And learning curve for the React Native is pretty low. So any full stack developer could jump into the development cycle and be on board in a bit like 2 weeks to 2 to 4 weeks, I would say, which makes it really accessible to a bunch of engineering teams, engineering functions to quickly move forward. But at the same time, I want to warn you guys that a bunch of engineers, full stack engineers who actually dealt with that learning curve and started producing features, that might lead to, that has risk leading to raising technical debt, because we still need to keep in team some of the experts who are actually taking care of high code quality standards and keeping the architecture kind of maintained and followed. Another benefit is the broad talent accessibility. It is the largest community of engineers, the JavaScript, and we using React Native is TypeScript, which is basically located in the same ecosystem, which makes us easy to onboard people, even with different backgrounds other than JavaScript. Some of, like, I think all of the engineers actually once, at least once tried JavaScript, at least once built some JavaScript features. So it's pretty easy to find the JavaScript experts and some of the React front-end engineers who could be easily trained to build React Native apps. And if business has not only mobile app, but also like website, backend, that could lead to unified ecosystem using TypeScript. On backend, you could use Node.js. On front-end web, could be used React. And the mobile website could be used React Native. All of those three parts will share the same concepts, same programming language, and basically it's easy to build full stack teams that actually can deliver based on the same, like, live in the same ecosystem and pass knowledge to each other and being full stack. So the product roadmap becoming more important than engineering roadmap. Accelerated market entry. With all those benefits, what it means to the business is actually, we can actually move fast to the market. We can iterate fast. We can build features, rebuild features, iterate, and release as much as possible. We have pretty rich experience in building CI/CD on top of React Native. And there are pretty amazing tools in the ecosystem to use. And yeah, basically, market entry is becoming really, really easy with React Native. Moving forward, like, I'd like to talk about the performance challenges that we want to talk about today, and we want to discuss. So all these advantages are what is the bright side of the moon. So what's on the dark side of the moon? What we've seen, what challenges we've seen across these years of the development, different React Native apps. And React Native is not very good with complex animations. If I were starting building the mobile app game, I would not pick React Native. I would probably stay with native, like Swift or Java for Android. And what React Native is good for is a lot of functionality. But when it comes to the complex animations, like I'm not talking about transitions of the page, like small animations of popovers, modal windows, and how transition happens between screens. I'm talking about the really interactive animations. That's where React Native is not the best solution for. If app has like 10% of the functionality based with complex animations, it still can work. But if 90% of the app is really based on interactive animations, I would actually go with Swift and Java for Android. Another big challenge we faced with, again, in Techstack, we have different cases. Some of our clients come to us and with existing code base, with existing technical debt, and we need to assess that. And afterwards, come up with the plan for resolution, what to do with that code base so that investment in engineering not becoming waste. And the most common issue, which leads to bad performance, is lack of state management strategy. So what state management is, why it's so important. Basically, in React Native, if user sees the screen, all that data that rendered on the screen, all titles, plain text data, images, whatever it is based on the single object called state. So React renders the state of that object, basically. If you change certain data in the state, React Native will re-render the screen and show the updated version. So the most common issue with state management we faced with is not very well managed state. It could be Redux, it could be Mobex, but I was trying to come up with real life example for this. And the best I came up with was imagine the 150 floors building, and you're sitting in the one of the floors, let's say it's 50 floor 55 in single room, but you need to keep in your head all rooms in all floors. And then how easy is that to navigate between rooms on your floor? Probably not that easy, given into account that you need to think about like all the rooms of that building. So the right state management strategy would be here is to keep in your head like probably your floor maximum, or maybe even less, like your neighbor rooms, so you can easily navigate because it's becoming like simple decision for you. The same is React Native. If a state is mismanaged, app tries to actually memorize all the states of all the screens which are not even accessed by user. And every time something changes, some data changes, let's say, to render something like we want to open modal window or enter text into some text field. What happens with mismanaged state is we actually change the whole state, like app changes whole state and re-renders everything that is related to that. So that's bad. That leads us to actually waste of how to say, I would say it better, like misutilization of resources, hardware resources of the phone, which leads to a drop of FPS. And while architecting the React Native apps, we need to think of the nature of React and like the design patterns it was invented based on. And depending on state management libraries people using, it also important to understand the philosophy of those. So for example, in Redux is based on CQRS, command and query segregation pattern. Mobex is based on MVVM pattern. So basically understanding those patterns allows us to design models more efficiently. And when it's not designed well, it leads to really bad performance and it's becoming skeleton of the app, and it's really hard to refactor that. And the last point here, like last challenge I want to mention today, is the third-party component management. As I mentioned, the community is huge. There are memes that every second certain number of JavaScript libraries getting released. And we need to be really cautious on picking and careful on picking the right libraries, because based on those libraries, the app size, it really depends on the amount of those libraries, plus update, like version update process could become really a big mess, which leads to which might block us for updating React Native itself, navigation modules, which actually together with updates, they have like pretty cool stuff on improving performance. And some of the engineering teams becoming locked for updating the versions because of a lot of dependencies and staying on the older versions. And that creates huge snowball of technical debt. So my recommendation here is to actually keep it as thin as possible, as lightweight as possible. Use only libraries that you cannot avoid. One more challenge I'd like to highlight is threading model. Basically, React Native, architecture of React Native is something we won't discuss here. But in simple words, React Native is single-threaded. It's actually declares that it's multi-threaded. As you can see here at the bottom, we have UI thread and JS thread. But these two threads are synchronized, means that they cannot be executed in parallel. And one of the common mistakes, issues appearing with React Native performance is when some of the complex animations are built based on UI thread, like native UI thread, and the other animations are built with JS thread. And while these two threads intersecting, FPS drops significantly, and it's actually noticeable by human eye. So here you can see that interruption happens. So for example, JS thread is where the screen transition happening. And while it's happening, we, for example, on the newly appearing screen, we have another animation, some, I don't know, complex animation built on UI thread, which actually interrupts the transition from the screen, basically interrupts transition of the screen on very short moment and starts animating based on UI thread. And those two animations are conflicting between each other, and they actually rendering piece by piece, part by part, and they share the same FPS, which leads to a drop of FPS on both UI thread and JS thread. So my recommendation here would be actually to stick to JS thread if there are no complex animations, and on places where there are complex animations, minimize JS thread interruptions into UI thread. Might be, my goal here is to keep it high level. Like, I don't want to go too technical. I want to talk about more strategic kind of decisions here and what we need to pay attention on. But this is very important piece on why people might avoid React Native, because it's hybrid solution. One of the best apps I used on React Native, one of the best examples for React Native, like how it's performing well with the animations and UI, is a Discord app. I would recommend to try it before deciding on React Native versus Flutter versus native. Cool, cool. So let's get back to the strategic part. And here we are gonna talk about tactics. We talked about challenges. I mentioned some of the solutions. I mentioned some of the recommendations, but here we collected some of the tactics that are commonly used in any products we build. First is robust architecture design. Architecture is the key. We have an example of architecture that was created 7 years ago, stands still today, and keep quality high, and keep teams enabled to deliver fast and keep technical debt low. And some of the highlights of those architectures, like we need to keep architecture modular, so we can have dedicated engineers for each module. But together with that, we need to set rules of communication between modules. Another tip here is as isolating components to preventing cascading issues. And strategic planning of the third-party integrations. We need to make sure that any third party we integrate into app actually has a roadmap. That we need to look at any third party that far, not only GitHub stars of that library, but in general, who is using, like which company is also using that third party. Research some of the success cases, look at the amount of GitHub issues, how many bugs are actually reported, and the speed of resolution of that bugs for this for any third party. And of course, if it's loved by community, GitHub stars is the great indicator of that. But also we need to have also our own judgment. Like, okay, what is the size of this package? How many dependencies this package has? Because if we look at node modules of the React Native project, and if it has like hundreds of node modules there, which has also dependencies, that could become really a big problem for the security purposes, for the updating version purposes, etc. So we need to be really careful with picking third parties. In that way, we can keep the app lightweight, performance predictable, at least controlled, I would say. The second highlight here, second tactic, is the one of my favorites. It's a design system. Using React Native without design system leads to UI inconsistencies, and it's becoming really like it's creating huge waste of time of moving pixels around. That's one downside of that. Another downside is that all components that engineers build with a product without the design system, most of the components are actually embedded into the screens, which makes it really hard or close to impossible to test components in isolation, like write unit tests for those components or behavioral tests or snapshot tests. So I would like to encourage everyone to look at component-driven development approach, and which also allows us to do component-based testing. Basically, we have component, we wrap it with a bunch of tests, we can QA it separately. We don't need to wait until like whole screen is built to start testing it. Plus, it also enables teams to distribute work. In this case, with having design system and component-driven development, engineering teams can split features, which usually could be done like by a single person, that the same feature could be done by 2 to 3 developers, which makes it like much faster to deliver. Yeah, the performance first development approach, we're talking about performance like whole webinar, but regular performance testing and also there should be very well established monitoring on technical debt, amount of errors for the app, amount of crashes, fast investigation of those crashes. And one more thing here with the performance first development approach, all apps most of the apps conducting backend to actually retrieve data and save data, or even do some real-time stuff. So backend should be reliable part of the experience. So what we do, we actually have a lot of automation testing for the backend, like integration testing, unit testing, load testing, performance testing, and we need to keep the API response really low, like let's establish up to 100 milliseconds, which is pretty good result. That actually leads to faster UX for the users. So this is the tactics, tips, what to pay attention on during the beginning or even in the middle of development. These are questions that would be great to ask to the engineers, or in general, like question yourself or question the engineering with this. The next step is I'd like to share some of the cases we worked on, some of the challenges, some of the successes we achieved. And one of the products we still actually continuously working on is the fundraising platform. This is the case which was started 7 years ago, and MVP was released in 2 weeks. And now we have around 50 engineers working on this. It's a big, successful startup. It was started, now it's a growing company. And yeah, we learned a lot on this case. What we have here, we invested initially, like from the first day of development, in CDD, component-driven development, in design system using Storybook, in really high quality expectations for the high quality of like code standards, output quality, like quality assurance, automated tests, etc. So we established the high bar initially, and followed that high bar, even raised year over year, challenged ourselves year over year to actually achieve the maximum performance and lowest technical debt possible. And yeah, the solution is very well done architecture, very well thought, tested, invested into design system, and the performance first development approach allowed us to actually deliver that in 2 weeks, MVP wise, and over 7 years of iterations, still evolved to something better. I'd like to highlight technologies we used, basically React Native as the base. We used Swift to do some of the native features. React Native can easily combine Swift or Objective-C native iOS or Android features into the app. So some modules could be actually fully built on native technologies. Java for the Android implementation of the same native technologies. Mobx State Tree for the state management. and Sentry for the error tracking, the error management. All of these are highly recommended and proven. Some of the highlights for the third-party libraries, the camera integration, integrations, video players. Also, we've integrated here ID verification system, which is much like very complicated system. We spend a lot into making sure it's smooth, and pay by bank solution integration, which resulted to which I mentioned, the 7 years part, the integrated 12 paged packages and custom native modules, which is basically what I mentioned about the Swift and Java for the native part. We achieved 99% on Google PageSpeed Insights, and something also amazing, we have more than 1 million downloads of the app in App Store, which also something that not included in the presentation, but I'd like to highlight is the average rating of the app with this amount of users. We have 4.9. Another case I'd like to highlight is the pretty fresh one. We just released months ago this app, the community app for readers, which has the digital bookshelf. And this is very interesting case where we actually needed to do a bunch of complex animations and dealing with that UI thread, JS thread situation. And yeah, you can try and download it and see what it resulted in. It's called ILIAD books, for those who are interested. So it's fresh. Like we started development somewhere in February, and we've built that app from scratch, faced with complex animations, challenges. The iterations were pretty fast, like as any startup, a lot of iterations, a lot of user feedback, and we really need to deliver to users what's not working for them. We need to understand market more based on analytics, and this is critical phase of any startup, to be really reactive at the same time as being like really proactive with delivering new stuff. React Native plays a huge role in this, and at the same time, as we do in Techstack for any of our projects we're working on, we're setting the highest quality bar possible for this based on circumstances. But in this case, even with that like insane pace of development, performance optimization was not sacrificed, because lessons learned over the more than 7, I think it was 8 years total React Native experience. So as you can see, the tactics and tips I highlighted before worked really well with the second case here in this. Also very well thought architecture, very strategic on third-party integration, and how we actually prepared the reanimated integration into this complex animations part. Performance first development approach. So all been used. Technologies wise, we use React Native. The difference between previous case and this one is that previous case is built on state management based on MobX, and this one is built on Redux toolkit. It's 2 different approaches on how to actually manage that 150 floors building in your app. Both solutions are great, but both require really professional architecture and require some like well design on the modeling and usage of the state. Sentry, very well for the error management, Amplitude for the analytics, TypeORM, and OAuth for the authorization. Cool. Yeah, the results of that adventure. Successfully released on the App Store and Google Play Store. We have insane, pretty cool feedbacks of the app from the early adopters. And yeah, this has been like pretty cool journey, which actually continues. The engineering team working on new features for that. And summarizing all this what's been said, I want to share the takeaways, but not only from this webinar, but also for all these years of experience. And I want to share some of the expertise we gained and takeaways. And basically, the one is performance is important. Do not ignore performance. A bunch of founders are actually in huge hurry to deliver whatever required by business, and being blind by like for the engineers when they kind of warning that this could lead to something bad. But need to be open and really do not underestimate the role of the performance from the initial step of the development. Architecture, like any code base, should be modular, and especially in the React Native, keep things modular. Make sure that it's not becoming that snowball of technical debt, and all those foundation needs to be established on the initial phase of the architecture. Architecture need to be well thought, and it doesn't require to be like perfectly matching a company in 10 years, perfectly matching vision, but it needs to be flexible enough, and it needs to protect from the future risks like growing technical debt or performance issues or quality issues, because cost of the bug is increasing as company is growing. And even if like initially cost of bug pretty low with low amount of users, when user base becoming huge, cost of the bug becoming the same, like also huge. So the third point, third takeaway is third-party libraries needs to be very well assessed, and do not hesitate to spend some time on R&D, on researching the value for the from the third parties. Conduct regular performance audits. That could be done by dedicating like performance sprints once in a quarter, or creating some engineering processes, engineering roadmaps, and executing those. And the last takeaway is the design system and CDD. Highly recommend, and that actually helps to build really sophisticated, efficient, and consistent UIs that are protected by random issues, because components are tested in isolation, built in isolation, and then they just used when they need it. Thank you for the attention. It was pretty quick webinar. I know that's how it's supposed to be. And these are my contacts in case you will have any questions after watching it. And finally we got to the questions section. Sorry for not responding in chat, because okay, so we have 2 questions here. We have 3 questions. I'll start with first. I'll try to be as quick as possible. In your experience, what are the most effective ways to optimize state management for high performance in React Native? The most effective ways to actually unit test, if it's MobX state tree or MobX, need to pay attention on definition of types and how each field is observed. It could be frozen, it could be dynamic. Make sure you have as small amount of as possible fields and models that are actually observed. And it's better to use some static objects to actually decouple that from state. If you have something that's not supposed to change, that should not be part of the state. For the Redux is actually one of the most challenging state management systems. For the Redux, need to test the reducers and actions by unit tests, keep them as a pure functions. And the optimization path is to actually design for the Redux optimization way. My favorite is to design state from scratch, like draw it, and then compare to how it's actually looking today. And by that difference, you could easily create plan of optimization for the Redux. Hey, thank you, Alexei. So Vladislav, what are some common pitfalls you encountered when refactoring large-scale React Native apps for performance? Yeah, the misuse of state management is the most common pitfall, especially because even if you have 30, 40 engineers in the team using the same code base, same state, it's really hard to keep state clean and make sure that this state is distributed. And I've seen the state being singleton, like single state for the whole app, doesn't matter, doesn't ignoring all the modules decomposition. And that whole state actually was mutated from different places. So app reacted randomly. It could be used, like some data could be changed in one place that automatically changes data in like very different place. So users would see some magic happening in the app that is really unexpected and can lead to high cost bugs. Thank you for the webinar, Ivan. I have one question. How do you balance the need for rapid market entry with the time required for performance optimization? If we invest a lot into performance optimization initially, we can keep that investment lower in future. We just need to track and monitor it and fix as soon as issues appear, or even try to be proactive on that. So I would say that it was investment initially, and then it's becoming easier. When that investment was not made initially, the performance, I've seen companies dying because of bad performance. I've seen apps being developed over 2 years, not on with React Native. It was another technology used called Ionic, also a hybrid solution for the mobile app development. It was app similar to Slack, but it was before Slack actually was released. And yeah, that very bad performance led to reduction in users, reduction in retention, and really bad feedbacks. And it's really hard to recover from that. So it makes sense to actually raise hand as an engineer and provide some arguments why performance is important, why architecture is important, why we should not ignore certain things. rather than dealing with that snowball when it's already too late. Okay. I hope I answered all your questions, guys. Thank you very much. Try to keep it short. It looks like we are right in time. Thank you for your attention. And yeah, if you guys have any questions, feel free to contact me over here. I have my contact information. And yeah, that's it. Have a great day and see you later. Bye, everyone.